Let's look at the four main steps for naming an alkane. We're going to identify the longest chain. And in the situation where you have two options and the chain length is the same, you make sure the parent chain is the one with the greatest number of substituents. So it is the longest, and it is the one with the greatest number of substituents. Next, identify those substituents and give them a name, whether it be a common name or IUPAC name. Number 3 is numbering the parent chain such that you're giving the substituents the lowest number possible. The first substituent should have the lowest number possible. If there is a tie, then you choose the chain in which the second substituent has a lower number. If that's a tie, then so on and so forth. And then the last, number 4, is to arrange the substituents alphabetically. This is going to be straightforward if you remember that you ignore prefixes except for ISO. ISO is the one prefix that we actually include in the alphabetical naming. If we look at this example and try to name it, our job is going to be to find the longest possible carbon chain. The first thing we see is this ring that is 6 carbons. So the question is the straight chain portion out here longer than 6? So pick any end you want. 1, 2, 3, 4, 5, 6, 7, 8. Yes, it is. Therefore, that cyclohexyl group will be a substituent. So you'll have the cyclohexyl, is how that'll be named. You'll have an ethyl, you'll have a methyl here, and a methyl here. So we need now to assign the locants. So how do we decide where the end of the chain is that is carbon 1? Remember, you number such that your first substituent you run into is going to be on the lowest number possible. So if I started from the left and I said 1, 2, the first substituent would be on carbon 3. If I start from the right, however, the first substituent is on carbon 2. So that's better. So I'll keep going, numbering in that fashion. So the longest carbon chain I have is octane. So write down the parts you know. You know that your parent is 8, so it's oct. You know it's an alkane, so it's ANE. You know that on carbon 2 you have a cyclo, hex because it's 6, YL because it's a substituent. Notice that between the 2 and the C of the cyclo, between a number and a letter, there is always a dash. On carbon 4, I have an ethyl. On carbons 5 and carbon 6, I have 2 methyls, so I need to say dimethyl. Now I need to put these in alphabetical order to actually put my name together. To put them in alphabetical order, you make sure that you do not use the prefixes such as di, tri, tetra. You do not use sec, you do not use tert, you will use iso, and you will use the C of cyclo. So with the dimethyl, we're using the M. With cyclohexyl, we're using the C. If you have 2 different cyclo groups, then you will defer to the H at that point, but we don't have that situation here. You use the E of ethyl. So writing those out properly now, my full name is going to be 2 cyclohexyl, 4 ethyl. Notice again there are dashes between letters and numbers. And then 5, 6, separate numbers. 5, 6 dimethyl. And the root is octane. Alright, if we look at this next example, again, we need to find the longest chain with the highest number of substituents. So let's just start trying. 1, 2, 3, 4, 5, 6, 7 is an option. 1, 2, 3, 4, 5, 6, 7. Uh-oh, another 7 is another option. If we keep looking, 1, 2, 3, 4, 5, 6, 7. Yet another option. And 1, 2, 3, 4, 5, 6, 7. So the question is, which of those is actually the best option? And if we go towards the rule that says it's not just the longest chain, it's the longest chain with the most substituents, then what we're looking at is this option. Because if you look in this one, you have 1, 2, 3, 4 substituents. Every other option we looked at had fewer. If you want to go back and play with them, you can. Now we need to decide how to number the chain. If we start from the bottom, then 1, 2, my first substituent ends up on carbon 2. If we look at the other option, 1, 2, 3, the first substituent is a higher number. So starting down here is the way to go. So on carbon 2 we have a methyl, 2-methyl. We have a 3-ethyl. We have a 5-methyl. We're going to need to combine those in the name. And we have a 4, 1, 2, 3 carbons, so that is a 4-propyl. And because it is 7 carbons long, our root is hept. And it is all single bonds, so it is an alkane, A-N-E. Combining all that, we'll need to put everything in alphabetical order. So the methyls, obviously both are going to use the M. P for propyl, E for ethyl. So ethyl would come first. So 3-ethyl. Next would be the M for methyl, and there are 2 of them, so I need to combine them. At 2 and 5, di, because there are 2 methyls. So we've taken care of that one, and this one. And now we have the 4-propyl. Making sure you're paying attention that dashes separate numbers and letters, commas separate numbers. Took care of that substituent, and now I just name the root as hept because it is 7 carbons long, A-N-E because it is an alkane. So the final name is 3-ethyl 2,5-dimethyl 4-propyl heptane. So one skill is to go from structure to name, and obviously the other that's going to be important is to go the opposite direction from name to formula. So if we look at A, we have 3-isopropyl, 2,4-dimethyl, pentane. So the pentane, I'm going to start with the fact that that is my 5-carbon parent chain. So do your normal bond line zigzag starting at 1, 2, 3, 4, 5. So that takes care of the pent and the fact that that's only single bonds. Start at one end for numbering. And now you can put in your substituents. At carbon 3, I need to have an isopropyl. At carbon 2, I need a methyl. And at carbon 4, I need a methyl. Taking a look at B, 4-ethyl 2-methyl hexane. Hexane is my root, so 1, 2, 3, 4, 5, 6. Number from one end to the other. I have an ethyl on 4. Now I could have just as easily drawn that way. As long as it is a 2-carbon chain, it is fine. And then on carbon 2, I have a methyl.